Hello everyone, welcome back to the channel. Today we are going to talk about kinematics. All right. So this is actually past papers from the year 2021 and then I think 2022, 2020 and then 2021 combinations that I have. There are quite a lot that I want us to give it a try, okay? So we'll solve as many as possible. I'll put the link to this particular worksheet in the description below so you can download it and then solve alongside with me. If you haven't subscribed to the channel already, then please do so now and let's get right into it. So we start with this very first question. It says that a particle moves in a straight line so that t seconds after passing through a fixed point O, its velocity is given by this. All right, so that is velocity. And now we are told that the distance, we should find the distance, okay, between the particles' two positions of instantaneous rest. Now, instantaneous rest means that velocity is zero, okay? If the particle is at rest, it means that it is not speeding anymore. It has just stopped speeding, basically. So V is zero. All right, so if V is zero, then we can say that we can just, this is velocity that, they gave us. So we can say that 3t squared minus 30t plus 72 is equal to 0, right? Now, this is a quadratic that you are going to solve. I am not going to solve this quadratic. I'm just going to put it on a calculator and then solve it with everyone, okay? And I'm doing this because I believe we can all do it and it will save me time, okay? All right, so it's a quadratic. I have 3, negative 30, and then 72. This will give me t equals 6, and then t equals 4. All right, now they said that we should find the distance between these two positions, okay? Now, point is, if you have, how do I even start with you? Let's say you have distance, okay? And then you differentiate distance. So you have ds dt, that is going to give you velocity, okay? And if I have velocity and I differentiate it, dv dt is going to give me acceleration. So now that means if I integrate acceleration, I'll get velocity. If I integrate velocity, I'll get distance. So now they gave us velocity and they want us to find a distance. So I just have to integrate this velocity, 3t squared minus 30t plus 72 dt, okay, from 4 all the way to 6, and then I'm done, right? So I'm going to have 3t cubed over 3 minus 3t square over this over 2 plus 72t, all right? And then we are integrating from 4 all the way to 6. And this is basically, this 3 is going to get rid of this 3. And then this 2 goes here 15. Yeah, so that's it. So that means that we have 6 cubed, all right? And we have minus 15 into bracket 6 square plus 72 into bracket 6, all right? Then we subtract from 4 cubed, right, minus 15 into 4 square, and then we have plus 72 into 4, and then this whole thing gives us, you know what I will do? I'll just put the entire integration on it from 3 t square minus 30t plus 72. I'm integrating from 4 all the way to 6, and that would give me negative 4, right? But here is the thing. You are looking for distance. The displacement is negative 4, no problem. But since you are looking for distance is the absolute value of displacement. So you can just call it 4 instead of negative 4. It's just 4. You are looking for distance, so it's the absolute value. Then we are told to find the acceleration when t is what? 2. Now, remember, you have your velocity to be v equals 3t squared minus 30t plus 72. So if you want acceleration, then we have to differentiate the velocity with respect to time, and that is going to give us something like this. We are looking for the acceleration when t is 2, so that's 6 into 2 minus 30. That will give us 12 minus 30, that's negative 18. So we can say that when time is about 2 seconds, the particle is even decelerating. Okay, the negative means that, the speed is going down. All right. Then we look at this question that says that particle P moves in a straight line such that t seconds after passing through the fixed point O, its acceleration, which is a meters per second, is given as this. So that's a. Now when t is 0, the velocity is 18. We should look for the time at which the particle P comes to instantaneous rest. You know, that is when velocity equals 0. So that means that we need to find the velocity in order for us to equate it to 0, okay? So, acceleration is negative 6. If I integrate acceleration, I get velocity. So that becomes negative 6t plus c, okay? Now, once you have something like this, it means that we need some parameters in order to find a constant c. They told us that t is 0 and then the velocity is 18. So that means that velocity is 18 when t is 0. That gives us c equals 18. So we can say that the velocity itself is negative 6t plus 18. Then we are told that we should find the time when it's at instantaneous rest. So velocity equals 0. That implies that negative 6t plus 18 is equal to 0. So you have 6t is equal to 18, t giving you 3, right? 3 seconds, basically. Okay. Now, they said that find a distance traveled, distance traveled by this particle in the 10th second. Well, in the 10th second means that they are interested in from t equals 2 to t equals 3. Okay, so when they say the 10th second, you need to go back 1 second and then capture from that second to the argument they are telling you. So 10th second mean you are doing it from 2nd second to 3rd second. If they say 4th second, you are doing from 3 to 4. If they say 10th second, you are doing from 9 to 10. Okay, keep that in mind. Now, so basically what we want to do is to integrate our velocity, because we want distance, so integrate velocity, which is negative 6t plus 18, okay, from 2 to 3 dt. So that is basically going to give us, that's negative 6t squared over 2 plus 18t from 2 to 3, okay, and that will give us, check this thing out, this will go here 3, so that's it. So that means we have negative 3t squared plus 18t, all right, from 2 to 3. So that means that we have negative 3 into 3 squared plus 18 into 3, okay, minus negative 3 into 2 squared plus 18 into 2, okay. And then I'll just put the entire thing on a calculator. I'm doing that because I'm not a student, and in the exam, please do this part separately, this part separately before you put the final answer down, okay? All right, so I'm integrating negative 6t plus 18 from 2 to 3, and that will give me 3 meters. Is the distance in meters though? Yeah, is it? Anyways, yes. Since the speed is in meters per second, then the distance is actually in meters. Okay, cool. Now so that's it. Yeah, let's move on to the next question that says that at time t seconds, a particle is traveling in a straight line with this acceleration. So we know that a is equal to 2t plus 1 to the power negative half, okay? Now, when t is 0, the particle is 4 meters from the fixed point. So when t is 0, we can say that the distance is 4 meters, okay? And then when t is also 0, the particle is traveling with the velocity of 8 meters per second, okay, away from 0. Cool. Now we need to find the velocity. They have given us acceleration. That means we have to integrate it. So velocity is basically the integral of this particle, okay. Now that means that we are going to have something like if we integrate this, we have 2t plus 1. This is negative half, so I add 1 to that. I have half, and then I divide by half. Okay. However, you see this guy here, bring it down to complete the integration. So obviously plus c. Okay. So that basically that means that we have v is equal to this guy here will cancel that. So we have v is equal to 2t plus 1 to the power half plus c. All right. Now we said that when t is 0, velocity is 8. So that means we have 8 is equal to 2 into bracket 0 plus 1 to the power half plus c. So that is going to give us actually 1. So 8 is equal to 1 plus c, giving us c value of 7. Therefore, the complete velocity will become 2t plus 1 to the power half plus 7. Okay, and then you are done. All right, so the next thing that we want to consider, they said that find the displacement of the particle at time ts. That means that they want it to be in terms of what? T, okay? They don't want anything weird. Now, you know that this is your velocity. You have your velocity beautifully here. Okay, so that's what we are going to integrate. So we are integrating 2t plus 1 to the power half plus 7, okay, dt. All right, so this is basically going to give us 2t plus 1 to the power 3 over 2 over 3 over 2 into bracket 2. Always, whatever is here must also come down there. Then we integrate the 7, that should give us 7t, okay. Now, then we have to also add our plus c, obviously. Now, this is our distance, so we can simplify that and write 2t plus 1 into bracket 3 over 2 over 3 plus 7t plus c. Now, we were told that, look at this, when t is 0, s is 4, okay? So that means that we know that s is 4 when t is 0. So if I put 0 right here, I'm going to get still 1/3 from there, and then I'm going to have 7 into 0 plus c. So that means that I have c is equal to 4 minus 1/3. That gives us what? 4 minus 1/3. That basically gives us 11 over 3. So we can confidently write that the complete form will become 2t plus 1 to the power 3 over 2 divided by 3 plus 7t plus 11 over 3. Okay, and then we are basically done. Okay, and then you score your 4 marks here. All right, then the next thing that they want us to do is that they said that a particle moves in a straight line such that its displacement from blah 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 is given as this. So this is the displacement of the particle when time is from 0 upwards. Okay, we should find the displacement of the particle when it first comes to instantaneous rest. Now, the fact that they said it first means that there are so many times that the particle could have come to an instantaneous rest. They are interested in the first one. Okay, so now if you have the displacement to be equal to 2 plus t minus 2 cos t, and they want you to find when it comes to a rest, then that means that you want to say velocity is 0. So differentiate it. So velocity will give you 1 minus 2. If I differentiate the cos, I get negative sine t, and then you differentiate the t, that's 1. So basically you have v is equal to 1 plus 2 sine t. Now we are saying that the velocity is 0, so that it implies that 1 plus 2 sine t is equal to 0. That means that sine t is equal to negative half, and then we can say that t is equal to sine inverse of negative half. Now, hear me out here. Whenever you are working, okay, in in kinematics, things like this, angles are in radians. So quickly change your calculator to radians. It's very important. If you don't change it to radians, you are not going to get the correct answer. And then you find the sine inverse of 0.5, negative 0.5, and that is going to give you negative pi on 6. Okay, now, unfortunately, time is not supposed to be negative. So that means that we need to use what some books call it the cast method. That means cos is positive, all are positive, sine is positive, and tan is positive here. Now, this essentially means that if you have negative pi on 6, it means the angle is down here, pi on 6. And that is actually, if you look at the case that we have here, sine is negative. Sine is negative on two regions, in the cos region and then in the tan region. So that means that we can also say this is pi on 6. Now, you are moving from this side, which is 0, okay, all the way to 2 pi. So, but we go in the anti-clockwise direction. So the first time that it comes to a rest is this point, okay, and this is pi on 2. So that basically means that what you are looking at is pi plus pi on 6, and that will be what I think that's, you can say 7 pi on 6, okay. So it says that find the displacement when a particle first comes to this rest. Okay, so now the displacement, remember they gave it to us as this, okay, that's 2 plus t minus 2 cos t, right? And now we know that the first time that we can really use it in our calculation is 7 pi on 6. So we can say that our value is going to be 2 plus 7 pi on 6 minus 2 cos 7 pi on 6. So we can put everything on calculator. So that's 2 plus 7 pi on 6 minus 2 cos 7 pi on 6. And that, ladies and gentlemen, gives us 7.9397, right? So that's basically 7.40. That's correctly 3SF, all right? So that is the displacement of the particle at the time when it first comes to an instantaneous rest, okay? Let's continue the argument. They said that find the time that the particle next comes towards a rest. I'm just going to drag this guy down there for us to use it in our further analysis. Okay, so now the next time the particle will come to a rest will be when the particle moves, all right, from here all the way till it hits here. The whole thing is 2 pi, so that one will become 2 pi minus pi on 6. Okay, so you have 2 pi minus pi on 6, and that is 11 pi on 6. 11 pi on 6. Okay, so that's the next time. Then they said that find the distance traveled by the particle from time 0 all the way to 3 pi on 6. Now, I want you to check something out. Let's even use this thing again. If you look at this, 3 pi on 6 is here. 3 pi on 2 is there. So that basically what they are saying is that you are looking for the distance traveled from here all the way to only here. You don't go beyond, you reach only here, okay? All right, so what I need you to do is to first look at the first time that it had it in instantaneous rest, okay? You look for distance based on instantaneous rests, all right? So the first time it had its instantaneous rest was from 0, okay? From 0 all the way to, from t equals 0 all the way to t equals pi, what is it called, 7 pi on 6, okay? We check that thing out here, 7 pi on 6. And then after you have found the answer, then you do from t equals 7 pi on 6 to t equals 3 pi on 2. So that is the plan that you need to know. That when they tell you to find this distance, when there has been an instantaneous rest, you break it into 2 or more pieces, okay? You don't do it, you don't integrate from 0 to 3 pi on 2, you'll be wrong. Because first, think about it. This is how it works. It means that the particle could, okay, if this is your linear, graph, and you start from time 0, and you go to time 1, time 2, time 3, time 4. I'm just giving an example. A particle can go this way, have an instantaneous rest at what? 3, right? So, and then the particle will start to what? Decline, all right? The acceleration will decline like this and end probably is here. Okay, it's an example that I'm giving. Now, if you integrate from 0 all the way to 1, that means that you've captured only from, let me even use black, only from here to there. You see the mistake that you would do. But what you want to do is capture the entire journey. So what you do is that first you integrate from 0 all the way to 3. That gives you the first part of it. You see, from the beginning to 8 instantaneous rest. Then you integrate from 8 instantaneous rest to a final position. Okay, so that gives you this measurement plus that measurement. That is why I'm saying that you just look for the instantaneous rest, integrate from the origin to that instantaneous rest, then from that instantaneous rest to the final destination. Okay, keep this in mind. It will really, really help you. All right. Then the next thing that okay, so basically we just have to integrate the velocity. Do we know the velocity? We do not, do we? Yeah. Actually, the question even gave us the displacement, so we do not have to think about the velocity at all. Okay, so basically what we are going to do is the distance traveled from here to there. Okay, so if I have from 0 all the way to, from 0, let me even make it easy, from 0 all the way to here, then that means that time is basically 7 pi on 6, right? Then the next thing is from here to here. You see, since they have already given me the displacement, I just need the minute time travel within it. So from here to here, that is t is equal to 3 pi on 2 minus 7 pi on 6. Okay, then so let's see, 3 pi on 2 minus 7 pi on 6, and that's going to give us pi on 3. Okay, so we are going to do when t equals this and when t equals that. So let's go and grab the displacement. This is 2 plus, I think 2 plus what? T, 2 plus t minus 2 cos t. Okay, so the first part of the journey, let's call it S1. That will become 2 plus 7 pi on 6 minus 2 cos 7 pi on 6. All right, and that will give us 2 plus 7 pi on 6 minus 2 cos 7 pi on 6. Yeah, and that gives us 7.3972. So I believe this we have solved before. So let's look at the second part where we put pi on 3 there. So that's 2 cos pi on 3. So that's 2 plus pi on 3 minus 2 cos pi on 3, and that is going to give us that's going to basically give us 2.04719. Then now what I have to really do is to sum the two together. All right, so I'm going to get 7.3972 plus that, and then that means that my total distance traveled from 0 all the way to 3 pi on 2 is going to be 9.44 meters. That's it. All right, we cannot go to the 11. We cannot use this one, even though it's also an instantaneous rest. They are telling us to start from 0 and end at here. So that means that we are using this, and then we just move on from here to there, and then we are done. All right, so that's what we do. Okay, so the next thing that we work on is this particular question. It says that a particle travels in a straight line and it passes through point O. The particle is moving with this velocity. Okay, so I believe that we can just start, plotting it. If the particle is moving at velocity of 3, then it means that the particle goes this way. Then it says that the particle continues for 60 seconds. So from here to here is about 60 seconds. Then the particle decelerates. Okay, the particle decelerates for 15 seconds at this rate. So the particle will decelerate for about 15 seconds. So that means that this is going to be 15 seconds. If you add it to this, you have 75 seconds. And the particle's speed at that time was 1.6. Then we continue. So the particle decelerates again for, the next 5 seconds and then reaches its point. So it decelerates again for the next 5 seconds. So that will become ATS. Okay, so we've drawn the speed time graph for this, and then you have your 3 marks. So the next thing is that they want us to find the distance between A and O. Basically, they want you to find the area under the whole curve. Okay, so this is in, I would say 3 shapes. Okay, you can look at this as a rectangle, you can look at this as trapezium, and then triangle. All right, so we can solve it. Let's solve it and then drag it down there. You can see that we have 3 times, for the rectangle, 3 times 60. Then the trapezium become half into bracket 1.6 plus 3 times the height. And the height is basically from here to here, okay? And that's about 15 plus, and then the triangle become half base. The base is 5 times the height, which is 1.6. Okay, so we can just copy it now and then go and dump it down here. Okay, so we can just put everything on calculator. 3 times 60 is going to be 180. Then we have plus 0.5 into 4.6 times 15, right? Then we have plus 0.5 into bracket 5 times 1.6, and that is going to give us 218.5. All right. Find the deceleration in the last 5 seconds. So deceleration in the last 5 seconds. Okay, how do you do that? Well, this is a velocity time graph. Okay, so the gradient is the deceleration that we are talking about, and gradient is rise over run. Okay, so they said the last 5 seconds. The rise is this part, and that is your 1.6. Okay, and then the run is this part, and that is your 5. Okay, all right, and then you are going to write, don't negate it. Okay, I'm going to tell you why very soon. So you are going to get 0.32. Okay, they said find deceleration. I know that the last 5 seconds, okay, this particular part is definitely negative because downward sloping, yeah? That's why they said deceleration. Okay, so if you are looking for deceleration, any value you have there is assumed to be negative. So that's it. Let's look at this particular one. It says that a particle P moves in a straight line such that its displacement is given by this. So this is the displacement. They want us to find the speed of the particle when t equals pi. So we've been given displacement, and they want us to find the speed. That means the velocity. So the speed or velocity is going to be 10 cos 2t times 2. Okay, when you differentiate that, and then you are going to get, they said t is what? T is pi. So this 2 times the 10 is going to give us 20. So we have 20 cos 2 pi because t is that. Okay, so 20 cos 2 pi, I believe that's 20 cos 2 pi. Yeah, so our answer is 20. All right, then the next thing they are asking us to do is to find the value of t when the particle is first at rest. At rest, v equals 0. So this velocity that we have as 20 cos 2t, we are going to equate it to 0. If we go to 0, that means that cos 2t is equal to 0. Then 2t is equal to cos inverse of 0. And then cos inverse of 0 will give us pi on 2. So 2t is equal to pi on 2. And then that means that t is pi on 4. Okay. Then we are also told that we should find the acceleration of the particle when it is at first rest. So you know that the velocity is 20 cos 2t. So differentiate it. So acceleration is dv dt, giving you 20 times. When you differentiate cos, that's negative sine 2t. And then you go into the 2t, differentiate, you get 2. So you are looking at negative 40 sine 2t. Now, that means that they said at the time where it is at first rest, and that we found it in the previous, that t must be pi on 4. So you have negative 40 sine into bracket 2 times pi on 4. And that's basically going to become negative this thing, sine pi on 2. Now, sine pi on 2, I believe that sine pi on 2 is 1, so our answer is negative 40. Okay. All right. Then the next thing, the B part says that the diagram shows a velocity time graph for blah, blah, blah. And then from the beginning, we are told that the particle accelerates this. So the acceleration is 3.5 meters per second for the first 10 seconds of the motion. And then it had a constant velocity, all right, all the way for the next, 10 seconds. And the particle decelerates, and then it came to a rest here. All right. Then we are told that the distance traveled during the 20 to 25 seconds is this. Maybe it become useful along the way. Okay, so now they want us to find the value of v. This is what I want you to do. You see, they gave you the acceleration, all right? And now, think about this way. If I have acceleration to be 3.5, and I integrate it, I'm going to get a velocity of 3.5t, right? Now, for how long did the particle go to attain the maximum velocity? It was 10 seconds. So that means that velocity is equal to 3.5 times 10, giving you 35. Okay, so this guy here is 35. Now, they want you to find the velocity of k when t is what? 25. Where is it? T is 25. This is the velocity. Okay, so they want us to find whatever the velocity will be for about 3 max. Okay. So now, remember that we were told the particle travels from 20 to 25. The particle has this distance covered, right? So I'm just going to clean this part and then get more places to work with. All right. So think about it. From 20 to 25, that means that this becomes the boundary of that shape. And we are told that this is 112.5. Now, we do not know what this value is, so let's call it x. And then we know that the whole of this is 35. That's the velocity. So we can use trapezium, how to find the area of a trapezium to go about it. So because we know that the total space there is this, okay, that is equal to half into bracket 35 plus x, okay, times the height, and the height is 5 seconds, all right, because moving from 20 to 25, there's a height of 5 seconds. So that means that I'm going to have 2 times, I have 112.5 times 2, that's going to give me 225. 225 is equal to 35 plus x, all times 5, okay. Then I divide by 5. If I divide by 5, I get 45 is equal to this plus x. So that means x is equal to 10, okay. So I know that when the particle is at time 25, the velocity is 35 meters per second. Right, so the next question says that we should find the value of t when q comes towards a rest. Okay, so that means that, okay, what is the time here at this particular point? All right, now I want you to observe something. We have found that x is 10, right? So we believe that from here to here is 10. That makes from this way all the way, oh, that's terrible, from here all the way to here is 25, okay? So I'm going to do something. Just observe. If I extract the first, there are two triangles here, right? This triangle, all right, and then this smaller triangle. So we are going to apply the concepts of similarities from extended maths, okay? So the bigger triangle is this, and the smaller triangle is that. Now, from the bigger triangle, this is 25, okay? And then from the smaller triangle, this is 10. From the bigger triangle, from this side all the way to that side is 5. From the smaller triangle, we don't know, we call it T. All right. So, I mean, what would similarity say? Similarity says that we can say T over 5 is equal to 10 over 25. Okay, so T is basically equal to 50 over 25, giving us a value of what? 2. Okay, so now I'm just going to copy all this, all right, and then we take it down there. So we can just put it probably somewhere here. And then we can also copy this and bring it here. Okay, so that it will make the work nice. Okay, so T is what? 2. But the last, that's about 2 seconds there. But the last part is 25 seconds before it went to 2 seconds. Okay, so that means that it comes to a rest. At rest, okay, at rest, you know, T is equal to 25 seconds plus the 2 seconds, giving you 27 seconds. Okay, and then you are done. Right, then we come to this question. It says that we should find the distance traveled when T equals what? 40. That means that from the beginning all the way to here. Right, cool. So first, calculate the distance that the person covered from 0 to 10 seconds. The person covered about 50 meters. So that's 50 plus. Then from 10 all the way to this point, the person has covered another 50, right? And then from this point to here, the person has covered a distance of 10. Please don't write negative 10. It's distance that we are talking about, not displacement. Okay, so that's 10. That means that throughout, the person made a journey of about 110 meters. Then we are told that draw the velocity time graph based on what you are seeing, okay? Now, if you look at the first portion of the journey, the person was traveling in a straight line, so the gradient is the same. The rise is from 0 all the way to here. That's 50, right? And the run is 10. So this positive slope, that means that there's a gradient of 5 along the way, okay? So that is 5 along the way for the first 10 seconds. Now, the second part of the journey, the person was moving from here all the way to here. What is the gradient? Well, you can choose any rise over run to check it out. If I want to say that I'm using from here, let's say from here, I want to just form a rise and a run. All right, my rise is going to be from this point all the way to that point. From 0 upward to here is 50, so it means the entire thing is what? Is 60 here. All right, and then moving from 10 to 40 is what? Is 30. Okay, so that means that rise over run is going to be 20. Actually 2. But remember that it is negatively sloped, so your answer must be negative 2. Now, this is also a constant velocity coming down, right? It didn't change. Hence, you go to negative 2, and then you draw that all the way to 40. Okay, so this is how it's supposed to look like. All right. Then we are told that a particle P moves in a straight line such that its displacement from a fixed point is giving us, okay, the acceleration is actually giving us this. Okay, so we should then, given that P has a velocity of 9 when T is this, we should find the velocity at time T. So they want us to integrate the acceleration. So velocity is going to be the integral of 2t plus 4 to the power negative half, okay, dt. All right, so that is going to give you 2t plus 4 to the power half over half, okay, into brackets 2, plus c. That's the velocity. So you are going to have v is equal to 2t plus 4 to the power half plus c. They said that t is 6, velocity is 9. So 9 into bracket 2 into 6 plus 4, everything to the power half plus c. Now, if you check inside the bracket, this is going to give you 12. 12 plus 4 is 16. Square root of 16, that's 4. So that means that you are looking at 9 is equal to 4 plus c. Therefore, c is 5. So you can say that the velocity is going to be 2t plus 4 to the power half plus 5. Okay, and then you are done. Okay. Then the next thing that they want us to do is that they said, given that the displacement is 1/3 when t is this, we should also find the displacement in terms of t. No problem. They just want us to integrate the velocity. So the displacement is just going to be the integral of the velocity 2t plus 4 to the power half plus 5 dt. So it's going to give us s is equal to 2t plus 4 to the power 3 over 2 over 3 over 2 into bracket 2 plus 5t plus c. All right. Now, they said that, well, let me simplify this before I even go to that argument. All right. So they told us that the displacement is 1/3 and then time is 6. So 1/3 is equal to 2 into bracket 6 plus 4, 3 over 2 over 3 plus 5 into brackets 6 plus c. So what I'll do is I'll put that whole thing on the calculator. That's 2 into 6 plus 4 to the power 3 over 2 all over 3 plus 30, right? And that is going to give me, so I have 1/3 is equal to 154 over 3 plus c. So that implies that c is going to be 1/3 minus that, okay? So 1/3 minus our answer, which is equal to negative 51. So we can confidently write that our displacement is going to be 2t plus 4 to the power 3 over 2 all over 3 plus 5t minus 51, right? So this is the answer they should be looking for. So that is actually also a 2021 question. Like I said, this worksheet is mainly for 2020 and then 2021 worksheets. Now, let's look at our final question for the day. This also came in February, March 2021. I believe that this question is a question that, I mean, you really have to think small in order to answer it. It's about 6 marks, okay? However, I'm going to make it as simple as possible for you to fully grasp what they are asking us to do. They said that a particle P travels in a straight line such that blah, 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 blah. Now, this is the velocity within this time frame, and the velocity changes to this within this time frame. Okay, that's the most important thing. Given that after leaving O, the particle is never at rest, so velocity is never 0, and it is true. Think about it. This velocity can never be 0. This velocity can never be 0. Okay, find the distance between, okay, 1 and then 3. So that means that they are talking about this distance. Well, that means that the distance is from t equals 1 to 2 to 3, right? Now think about it. If you look at the velocities that they gave you, there's no velocity that captures from 1 all the way to 3, but rather it's in bits. So what do? Well, the first part captures from 1 to 2, so you can work with that part. What are you looking for? Distance, right? So you can integrate the first velocity, that's t over 2e, from 1 to 2 dt. Okay, when you finish, add your answer to the velocity from 2 to 3. Okay, that's, you integrate from 2 to 3, and that is the second part. Okay, so once you do this, you've captured both velocities. So unless you break it, you can't do it. And you need to know that there's no velocity that they gave that captures from 1 to 3, but rather you can break it as from from 1 to 2, and then from 2 to 3. And then, I mean, that's how students were expected to answer this particular question. Okay, so now let's integrate this one. Now that means that, remember, that half e is a constant, so you can just have 1 over 2e out, then you have the integral from 1 to 2 of t dt. And then this part will become 2 to 3 of, okay, let me just maintain it and then I'll integrate it later. So let's now start the integration. So you have this, and then you're going to have t squared over 2 from 1 to 2 plus, and then this is going to be the same thing but divided by a negative half, okay, also from 2 to 3. And then that means that this guy, we are going to have 1 over half e into bracket, then we are going to have, you put 2 there, 2 square over 2 minus 1 square over 2, okay, then we have plus, and then this is basically going to be negative 2 e to the power this, okay, t over this from 2 to 3. Now, this part, we are going to get 4 over 2, which is 2, and this still half, okay, and then for this part, we are going to get negative 2 e to the power negative, we said from 2 to 3, so negative 3 over 2, and then we have, you are going to subtract minus 2 into bracket this guy, and then you have 2 over 2, which is basically 1. And then, so that means that on this side, you are going to have 2 minus half, that's 1.5 or 3 over 2. So that 3 over 2, you let me not jump step here. I want you to fully understand what I'm doing. And then on the other side, you would come to have, I think that becomes 0, right? Because this whole thing is going to be a plus. Okay, so it's actually not 0. Hey, I nearly made a mistake. So this is going to be this, and then you have plus 2e to the power negative 1. Okay. So I believe now at this stage you can just write 3 over 4e plus this whole thing, this thing here. So we can just put everything on the calculator on this stage, and then that means that we are going to have 3 over 4e plus into bracket negative 2 negative 2e to the power negative 3 over 2 plus 2e to the power negative 1. And that will give us 0.0565. Okay, and then you are done. So this is really the distance between these two, and that is what we are expected to get. Okay, so this is the end of the lesson on kinematics. I hope you really understand it. I believe that you solved at this stage with me through the past papers, and so you should be fine by now. But if you have a question, you can put it in the comment section. I'll check it out when I'm available. Until we meet again, take care of yourself. See you next time. Bye for now.